Okay, so I just wanted to do a video kind of going over some of the nuances of the third exam. This is also going to be another 30-question exam, and it will be delivered in the sapling format, similar to last time. But this exam, I have eliminated all mechanism drawing questions. There were just too many issues with those, and so I have purged all of those from the question set. There will be questions where you will have multiple portions to answer, but they should be a little bit more straightforward, more of the drawing type of questions. And on this exam, I have also enabled the Adobe Flash Player, which I think is a little bit easier to draw some of the structures. So I will go through some things you need to be aware of about that, but you definitely need to make for sure that your browser is enabled for that, because it will not, that you will not be able to view the questions unless you have your Adobe Flash Player enabled. This is particularly an issue with Chrome, but I will show you, if you're using Chrome, I'm using Chrome, and I'll show you how you can kind of work around this. You need to make for sure you've installed the latest driver for Adobe Flash Player first, whichever web browser that you're using. And I'm going to show you right now with the share screen kind of what I'm talking about. Okay, so what you guys should be seeing now is the sapling homepage. Over here, if you click on the lock button here, where you would type in your address, you can see right here it has a Flash plugin. You want to make for sure that that is clicked to allowed. Chrome generally requires that you ask for permission each time before allowing it to just run automatically. So you'll want to make for sure that that's clicked to allowed, and then once that's done, it should be able to work okay. If you're still having issues with this, please reach out to the support hotline that I have provided for you. I will send an email out again today with that information to kind of assist you with that. Now, on this exam, I have gone ahead and given the extended time for those with accommodations, and you'll see the normal exam here. Again, you only want to click on one of those two links, depending on if you have accommodations or not. Those that have the regular time will be allotted 3 hours to take the exam, and then those with the extended time will be allotted 4.5. Same number of questions for each exam, 30 questions each. Again, this is open note, open book. But again, guys, be careful if you are talking with each other, if you're consulting third-party websites for answers like CHEM, like Socrates, like some of these other ones. That is considered to be academic dishonesty. In all truth, I cannot police it, but I am telling you now that it is, it really violates the student code, honor code. And I assume most of you are going to need this class for something in the future. So again, please be careful. I have tried to give you as much time as possible to do this exam, and I am going to show you some of the styles of questions that you're probably going to see on here. And so let's just go ahead and get into it. So I have some practice questions here that I've picked some variety of difficulty ranging here. But let's just get into it. So the first question that I've got, you'll notice the Flash Player is opening up, and I have a question here where it's asking me to do a chlorination of this system, and then your solvent here is ethanol. Now, this is very similar to what you would see with a halohydrin situation, except here you have an alcohol instead of water. So it's going to produce a halo ether. The question is after the chlorine reacts, which means you're going to end up with a with one of those three-membered polonium ions here on that double bond. The ethanol is going to come in and attack the more substituted carbon, because that's where the partial positive charge is going to be. most stabilized. I'm not going to draw all that out because that is in the notes and I have gone through that before. This is just more to show you how you would input the answers. Notice also in here it's singular for product, so it only wants one product. So even though there may be more than one stereoisomer possible, it's indicating it doesn't want you to do that by saying that. Also notice there are no hydrogens drawn on the structure, so I'm going to leave the hydrogens out as well. So I'm going to start off with a 6-membered ring. Then I'm going to kind of start to draw some of the carbon framework. So I'm going to just put all of that into place. Okay. And if I have predicted this correctly, the chlorine should go on this carbon over here, as I suspect the methanol is going to attack on this side. So that is going to be, come over here, click on this button, chlorine. Okay, and then for the oxygen, I'm going to have that over here, and now I need to put in another 2 carbon on that oxygen. Okay, so I think we've got all the components here for this species. So now I'm going to check, make for sure I have it right. Okay, so I did. Now the next one, again, this is kind of chapter 8 material, is where you've got an alkene, okay, and you have this butyl group, and you're treating it with HBr. Now, as soon as you see this with this kind of this alkene that's not very substituted, that should immediately get your hackles up that there's going to be some type of possible rearrangement chemistry going on there. So for this one, I think I will go ahead. I'm going to draw some information here about the question. Okay, and I'm going to go back to this page here so you can kind of see what I'm talking about. So what's going to happen here in this case is when you protonate this system, you're going to get a Markovnikov addition. So it's going to add hydrogen to the side of the double bond that has the most number of hydrogens and then the positive charge here. Okay, that's a secondary carbocation. So if the methyl group migrates over, so you get a 1,2 methyl shift to here, okay, well then now the positive charge is right here at this position. And so the bromide you would expect is going to add in at that position. Okay, and even though I'm not drawing in all the other hydrogens, you know that they are understood and are there. So that's what I suspect is going to be the major product in this particular case. So I'm going to go back to the share screen. Okay, notice all the hydrogens are here and it says to include the hydrogens. Okay, so I'm going to go ahead and do that. So I'm going to start by drawing in my carbon framework. So I have, let's see here, two carbons here I'm going to have up at the top. Then I'm going to have a carbon that comes down to this position, and then a carbon that goes over to here, and then a CH3 here. Now I'm going to do all the hydrogens here last. The next thing I want to tackle is putting in the bromine. Okay, and now I'm going to do my hydrogens. See this up arrow with the hydrogens? If you use that and you hover over to an atom and you click on it multiple times, it will pencil in the hydrogen atoms for you, but you've got to make for sure that you get them all in place. Okay, so I think we got them all drawn out. Okay, there we go. All right, so make for sure when it says to draw in the hydrogens that you do so like in this structure. Okay, I've got a lot of questions about NMR. Now, I know that the sapling homework goes into a lot of detail, and I did that lecture fairly quickly. I was giving you the major points of information. And that's really what I'm going to emphasize on this exam and on the final. There are lots of nuances to NMR, lots of them, okay? Things we didn't even talk about, such as J coupling and things like that that has to do with the distances between the splits. Do not worry about that. The major things that you need to understand for this exam is the number of signals, the splitting, and the location of those signals with the integration. The key things that we talked about in the presentation that I did. The PowerPoint goes into a lot more detail than what I did on that discussion, but I was giving you guys more of the major points you should focus on. You're gonna get into NMR a lot more in the laboratory next semester. So if you're feeling a little bit shaky on it, that's okay. You just really need to know the fundamentals. So looking at this, this particular problem, it wants you to predict what the NMR is going to look like. I've got an ester here, and if you look at this, I should have 3 different signals, and that's what this is indicating here as well. The question is which of those signals do you expect would be the one that's the furthest downfield? The answer is it's going to be the ones where the carbon is directly bonded to the electronegative oxygen. And because those hydrogens are more than 3 bond lengths away from these hydrogens over here, it's not going to be split by anything. So I suspect that that is going to be a singlet, which I'm going to put the singlet right here. And I'm going to indicate that there are 3 hydrogens associated with that signal like so. Okay. Now, the next one, if we're going to the signal that's the next furthest downfield, it's going to be this one right here, which is next to the carbonyl. Those 2 hydrogens right there are going to be split by these 3. So that means that's going to show up as a quartet. Now be careful when you choose that over here. The way they did this is singlet, doublet, triplet, then quartet, then pentet, then septet, then sextet. Okay, so this is the one you want for a quartet right here. And that's associated with 2 hydrogens. Okay, now the last one is going to be this CH3 group here. It's going to be split by those 2 hydrogens. So it should show up as a triplet. Why I put it up there. Put it down here. There we go. And it's going to associate it with 3 hydrogens. Okay. All right, now I'm going to check my answer. Okay, so I hope everybody see that this is I'm going to be probably a little bit less cumbersome than the last exam putting stuff in. So just be that's why I'm trying to do this stuff with the Adobe Flash Player this time, which is going to I think help with some of the drawing issues. Okay, now the next one says to draw the structure that corresponds to the following information. So you have a chemical formula, and you have 1, 2, 3, 4, 5 carbon signals. Notice 4 of them are over 100, which is indicating some form of unsaturation in the system, like the carbons are double or triple bonded to something, maybe even an aromatic ring. Now, let me go back to the main page here, and I want to show you guys something. So something I did not, I think, address with you all in here, but it is a fairly useful skill, is to think about how saturated a system is. So the chemical formula that was given to us over there was C7H8. Well, if you were going to talk about an alkane that had 7 carbons, the saturation formula for an alkane, and I do think I did mention this back all the way in chapter 4, is CnH2n plus 2. Well, so that means a fully saturated system would have something like this, C7H16. That is a fully saturated system. Well, if I look at the difference between the number of hydrogens, that's telling me that there's an 8 hydrogen difference in those 2 formulas, okay? Now, why that's important, and I'm sorry, I don't know why this focus is out. There we go. The reason why this is important is because every 2 hydrogens really counts for a form of unsaturation or a ring, okay? So each 2 hydrogens count as either a pi bond or a ring in the system. So this is telling me that I have either 4 rings together, I have 3 double bonds in a ring, I have a triple bond, 2 rings, etc. Okay, so it's a way of kind of keeping check of what you're doing. Now, if you remember, I said there was only one signal that was above or that was below 100, okay? So if you went out and you just tried to draw that, let's say with 3 double bonds and a CH3 like this, okay? This right here would fit the bill for the unsaturation, except for one thing. It's not, it doesn't have enough. This only would count for 6 hydrogens, and I would need 1 more. Now, that means that if I'm looking at this, this would have a chemical formula of C7H10. So even though you would have 1, 2, 3, 4, 5, 6 carbons, 6 carbons that would be above 100, and I think that's too many carbons that we would need in our particular NMR, because there's only 5 signals, and this one would give 1, 2, 3, 4, 5, 6, 7 signals. That's not going to work. So this is not only not symmetrical enough, but it doesn't have the right chemical formula. Well, what if I went ahead and connected everything together in a symmetrical ring, like so? Now, if I did that, well, that has 3 double bonds and a ring, which would fit the bill for my unsaturation. And if you count the number of carbons, you would have 1, 2, 3, 4, 5 signals, which is exactly what I would have. And one of those signals would be below 100 for the CH3. So if we go back to the original question here and try to pencil that in, put a ring, we're going to have a double bond, and we're going to do 1, 2, 3, and then we're going to have an extra carbon coming off right here. Okay, so if we check that works. Okay, so I'm telling you this to pay attention to the formulas also. If you get a question in this manner, to look carefully at the symmetry in the compound. I know there's questions in the sapling homework that deal with some 2D NMR information and something called depth experiments. Don't worry about those. I'm not going to have questions on those on this exam. This would be to the extent of the carbon, and I like questions that actually combine carbon with proton NMR, but I tried to pick questions that I thought were that looked a little bit intimidating, but you could actually unravel them if you thought about the chemical formula and some of the other information. Okay, the last question that is on here is a question where you've got an alkene, and you're making this this ether. So this is a methoxy ether with an OH, and you'll notice the stereochemistry is anti here, so you have 1 OH down, 1 OH up. So even though this is not the only product I suspect that would be made, to make this one here, okay, you would need to install oxygen on this pi bond, okay? Now, you could do that with ozonolysis, but that's going to cut the ring, and you still have the ring here intact, so you don't want to use it. The only other oxygenating reaction here is going to be this one right here. So this is a peroxy acid formula similar to MCPBA. So I'm going to use that as my first reagent. That should give me my epoxide. And then if the epoxide is attacked on the less substituted phase, this is something I went over in the notes, that's something that's going to be base catalyzed. So that means I need to use a base. And so if I use methoxide, that should attack at that position and open up and give you this particular ether. So this is something we went over at the end of chapter 11. So I'm going to check that. Okay, so that kind of gives you a rundown of some of the questions. I know that this is only 5 questions, but I tried to pick a few things, and more of this is about making sure you're comfortable and you can test your system with this with these 5 questions to make for sure that everything is up and running before you go in to take the exam. The exam will run through Thursday, so you will have until 11:59 on Thursday to take the exam. But again, remember the window closes at 11:59, so if you wait until Thursday evening to take the test, make for sure you give yourself 3 hours before that so you have the full time. In other words, start at 9 p.m. at the latest if you want the full 3 hours to take the test. And of course, with extended time, you would want to probably start the exam even earlier, probably 7:30 at the latest, so you would have the full 4.5 hours to take the test. Okay, so that was a lot to say, but I wanted to try to alleviate some of your fears coming into this to this third exam. Those of you who have sent me questions about the final, I will have some information about that probably coming once we get through this exam cycle. I am still in correspondence with the other organic instructors as to how we are going to tackle that. Anyway, guys, if you have any questions, please feel free to email me or post them in the comments section, and I will get back with you as soon as I can. Hope everybody's doing okay, and everybody take care, and I will talk to you again soon. Bye-bye.